three possible ways for Lyme disease to be transmitted. Number one, by the bite of an insect or tick that transfers blood. Two, in a pregnant woman, from the mother to the fetus via the placenta. And three, sexually transmitted. Lyme also contains co-infections such as Babesia, Ehrlichia, Bartonella, and secondary infections such as Mycoplasma, Candida, and viruses as HHV6, cytomegalovirus, and Epstein-Barr. Lyme is characterized by a spirochete infection. The spirochete releases bacterial lipoproteins, that is a neurotoxin. The BLP neurotoxin the helper T cells come along and pick up the processed antigen off of the dendritic cell. Then, the helper T cells proceed to pass the antigens along to another portion of the immune system called the killer T cells. The job of the killer T cell is to hunt down the spirochete infection and eliminate it by using the antigens to identify the Lyme disease. As the spirochete burrows into the body, it continues to spread its antigen onto the surface of healthy tissue and organs. The killer T cells follow as they seek out the antigen of the spirochete. In this process, the killer T cells begin to destroy healthy tissues and organs because they cannot differentiate between the antigen of the spirochete or the antigen of healthy tissue. As the killer T cells come into contact with the antigen located on the healthy tissue, we begin to see inflammation and destruction of the healthy tissue. This is clearly seen in autoimmune disease process, where the immune system cannot distinguish between self and non-self. As the spirochete is continuous disease treatment. There are three major focal points in the treatment of Lyme disease. One, the disease itself, which is represented by Lyme, its co-infections, and secondary infections. Two, the immune systems and other immune modulators. And three, the neurotoxins, or the bacterial lipoproteins in yellow, that usually take a longer time to clear up as the infection improves. As the immune system increases and the infection decreases over time, which is represented in the yellow line, we see the windows of symptoms improving. Also notice that it takes the bacterial lipoprotein neurotoxins longer to clear. This represents the ideal course of treatment. Unfortunately, this does not occur in the current methods of treatment. Now, let's review three common treatment scenarios. Number one, the patient is diagnosed with Lyme disease and then given 4 to 6 weeks of IV antibiotics. You'll notice it does nothing for the immune system except impair immune function, slightly shifting the disease over 4 to 6 weeks, and then you'll see the relapse once the antibiotic treatment ends. You'll notice the antibiotics do nothing to address the co-infections, the secondary infections, or the neurotoxins related to the Lyme disease. And it does nothing to strengthen the immune system. In the second scenario, you'll see the patient is using IV antibiotics, dietary herbs, and supplements. The IV antibiotics bring the infection down a little bit, and the dietary herbs and supplements slightly increase the immune system. As in the first example, once the patient stops therapy, we see another relapse. Causing inflammation, irritation, and damage to the peripheral and central nervous systems. Causing inflammation, irritation, and damage to the peripheral and central nervous systems. The problem remains. The number of cases of Lyme disease reported to the CDC do not represent the total number of cases that exist. Lyme disease, its co-infections, and secondary infections may represent more than 300 different medical conditions, such as chronic fatigue, fibromyalgia, and other autoimmune diseases. The following diagram is designed to help explain the various scenarios of chronic